Hi, so in this video we're going to be looking at geometric series questions. I've put here just the general formula. They are given the formula sheets currently. You can check whether they are as you're closer to your exam that they're still there. The key things that you need to recognise from them: U subscript n means the nth term, A is the first term, R is the common ratio, and N is the term that you're looking at. S subscript n, that's the sum to n, so that's the sum of the first n terms, and S with the infinity is the sum to infinity of your series. Okay, so the first question: a geometric series is first term 4, common ratio 3, find the 10th term and the sum of the first 6 terms. Okay, so the first bit we want to find the nth term, so we're going to use the nth term rule. Write out what you have, and I do recommend you do actually write them out. So we have A equals 4, R equals 3, and we're looking when n equals 10, and then you just substitute them into your formula, put it in your calculator, and you get your answer. Okay, then the second part of this question, sum of the first 6 terms. So we got the same A, same R, and now we have n equals 6, and we're looking for the sum to the nth term, so this is this one. And again, we just plug in all the bits. So A equals 4, R equals 3, N equals 6, and R equals 3. And then put it in our calculator and we will get the answer. Okay, so in this question, if A equals 20 and R equals a half, which term equals 5/8? This is a slightly harder question, but here we go. So we're talking about trying to find when which term gives us a certain answer, when we can get the nth term equal to something. So we use this formula. We have A equals 20, R equals half, and the nth term equals 5/8. We slot all our things in and we get this. Now we're trying to find n, and we need to sort of get n out of that formula, and the way we do this is by taking logs, because when we take logs, if you can remember, if we have something to the power can then be moved in front of the logs, and that just allows you to let that n escape from the power, and then you can solve for n. So take logs of both sides. That's what we're doing here. We bring that power to the front like I've just said there, so that gives you this one. You divide by the log a half because you want n on its own. Then you just put this in your calculator, and when you put it in your calculator, you just get 5 out. And so then you just have, quite simply, n minus 1 equals 5, and 5 plus 1 gives you 6. Okay, so we get, it's the 6th term when the term equals 5/8. Okay, so geometric series has third term equals 8 and the 6th term equals 27. Find the first term, the common ratio. You do this really by creating simultaneous equations. So you're given the value of the third term and the 6th term. So you use this formula to write 2 equations. Here they are, and now you can either use just divide the 2 equations, is what we've done here, or you can use substitution if you rearrange this and have A equals 8 over R squared, and you substitute that into there, and you'll get the same answer as you got here. So I've just divided, so when I divide A by A, I get 1, so that goes away. R to the power 5 divided by R squared, R to the power 3, and 27 divided by 8 gives me 27/8. I then take the cubed root, and that gives me 3 over 2. And then once I've got that answer, I can just substitute it merrily back to this one, and then that's going to give me my value for A. Now I know I go very quickly through these, but you can also always pause and re-listen to it again. Okay. Okay, so a geometric series has first term 50, and the sum of the first 3 terms equals 188. Find the value of R. Actually, the simplest way on this style of questions, where there's not many terms, is just to write out the terms. So you'd have 50 plus 50 times R plus 50 R squared, because that's what a geometric series is where you multiply by R every time you go up a term, equals 182. And that's from the question. And then you can rearrange that to get a quadratic. You can factorize it into 2 brackets, hopefully. So if we look at this, 5 times 5 is 25, 11 times minus 6 is minus 66, 5 times minus 6 gives you minus 30, plus 11 times 5 gives you plus 55, plus 55 minus 30 gives you the plus 25. And you can always use a quadratic formula if you're not very good at doing that. So this gives you these 2 answers, r equals 6/5 or r equals 11 over 5. Okay, so here we got a sample of sum to infinity. Sum to infinity equals 2. Now, just remember, when you have a sum to infinity equals a number, that means your r is restricted here. Okay, so sum to infinity, we can use this formula. And then the second term equals this, so we use this formula here. So we get these 2 formulas. And again, we can either solve them by substitution or just dividing. We've just divided here, so this becomes r times 1 minus r equals minus 3/4. But, you know, it's equally valid just to make a the subject of this equation and substitute it into that one. We then expand our brackets, and we get this. We multiply up by 4, so we get 4r squared minus 4r minus 3 equals 0. And then we can just factorize it into 2 brackets. So 2 times 2 is going to give me that 4r squared, and 1 times minus 3 is minus 3, and then 2 times minus 3 gives you minus 6, plus the 2 gives you minus 4. And then we just solve that. So we want to see when each of these brackets will equal 0. This one will equal 0 when r equals minus a half, and this one equals 0 when r equals plus 3 over 2. Now the key thing here, before we go back and substitute in to get a, is to note we can only have a sum to infinity if r is between -1 and 1. So this one we can discount. It comes out mathematically, but it can't be there for a solution. So now we just substitute the r equals minus a half into either of these equations, it doesn't really matter, and we get the answer with a equals 3. Okay, so that's the end of those questions. Please go back through it more slowly if I've gone too quickly. I hope it's helpful, and please see my channel or my playlist for more videos. Okay, bye.